This lecture is about language and the brain. The subject turns out to be, not too surprisingly, quite complex. But this should give you some of the basics about what is known about language and where it resides in the brain. The human brain, like all mammal brains, is divided into two halves, or hemispheres, which are referred to very practically as the left and the right hemisphere. Each hemisphere is further divided into different lobes: the frontal lobe towards the front, the temporal at the side, the parietal, and the occipital. The two hemispheres are connected by something called the corpus callosum, which we'll discuss in more detail in the next lecture. This structure is responsible for passing information between the two hemispheres. The outer rind of the hemispheres is called the cerebral cortex, which is heavily folded in humans, effectively giving us more brain real estate. It turns out that there are two major language areas located in the cerebral cortex. This was first recognized by French surgeon Paul Broca in 1861. Broca's patient displayed language deficits, and upon autopsy Broca noticed that a certain area was damaged, though now it appears that other areas were also affected. This area, located in the frontal lobe as shown here, was subsequently named Broca's area. And Broca famously concluded, "We speak with the left hemisphere," because the damaged area was again located in the left hemisphere in the frontal lobe. An acquired language problem, like the problem that Broca's patient had, is called an aphasia. Aphasias are commonly caused by strokes, trauma, as well as tumors. People who are affected by Broca's aphasia have a particular type of problem, though every brain injury is going to be unique. But in general, it can be said that Broca's aphasics comprehend language for the most part. That is, they understand the questions that are being asked of them. But their output is halting and slow. And often the patient seems to realize that he or she is making mistakes. So as a generalization, we can say that Broca's aphasia symptoms include hesitant, halting, labored speech, and yet the patient will comprehend language and also realize that he's making mistakes. A bit later in 1874, Carl Wernicke, or Wernicke, discovered another area now known as Wernicke's area, located in the left hemisphere, but this time in the temporal lobe. The temporal lobe is that weird side extension on the brain. Wernicke's aphasics display quite different symptoms than Broca's aphasics. Their comprehension of language is poor, and they don't appear to recognize that they're making mistakes. And yet, in contrast to Broca's aphasia, their delivery is quite fluid. Sentences sound like sentences of English in that the words, the nouns, and the verbs are all in the right place, and the syntax is good. This is sort of like Jeffrey Ellman's Orovingian Binks glorping the Mapador. It sounds like a sentence of English, and yet it's really meaningless. So here's an example of a conversation between a medical examiner and a person with Wernicke's aphasia. So the examiner is saying, "Yeah, what's happening here?" and pointing to a picture. And the patient responds, "I can't tell you what it is, but I know what it is, but I don't know where it is, but I don't know what's under. I know it's you, couldn't say I couldn't say what it is," and on and on. So you get a real sense of what it's like to have Wernicke's aphasia. So just to summarize, Wernicke's aphasics appear to have poor comprehension. They're not aware that they're making language mistakes. They create new words that sort of sound like words of English. And yet their syntax, the word order, is relatively normal, and the output is fluent with a normal intonation. The existence of these two areas was further explored by Penfield and Roberts, who applied weak electrical stimuli to these brain areas while the surgery patients were still conscious. In this way, they effectively were giving people different types of aphasia, albeit on a temporary basis. Amazingly, users of ASL or American Sign Language can also experience aphasia. Signers with Broca's aphasia have difficulty with output, just like speakers of English, while signers with Wernicke's aphasia have difficulty with comprehension and really making sentences that have meaning. Also, in some cases, aphasiacs or aphasics, like the creator of the Dilbert cartoon, are able to sing even though they're not able to speak. The term language dominance refers to which hemisphere these two language areas, Broca's area and Wernicke's, are located. Rather than both sides of the brain performing the same tasks, the brain is lateralized or specialized for some functions. One area on the left does one thing, and the analogous area on the right does something quite different. The right hemisphere, we know, plays a role in how something is said, whether it's angrily, fearfully, impatiently, and so forth. How something is said is called prosody, and in many cases, prosody is as important to language as is the meaning of the sentence. Damage to the right hemisphere causes difficulty in perceiving other people's emotions, failure to understand humor and sarcasm, as well as a monotone delivery. So yes, the right hemisphere does something that's important for language and communication in general. Oliver Sacks, the doctor from the movie Awakenings, who was played by Robin Williams, wrote that he was watching a speech by Ronald Reagan with a group of aphasiacs, and the patients were laughing hysterically, even though they couldn't understand what Reagan was saying. And Sacks concluded that aphasics were laughing not at the content of Reagan's speech, but at his prosody, his false tones, exaggerated gestures, and false facial expressions. The patients had damage to the left hemisphere, but the right hemisphere, which interprets prosody, or how something is said, was perfectly intact. So Sacks concluded that you can't lie to an aphasiac. A small number of people have language in their right hemisphere, and an even smaller percentage have these areas more globally distributed in both hemispheres. A relatively easy check for language dominance, as it's called, is the Dichotic Listening test. This test sends sounds to both ears simultaneously. The sound that's heard corresponds to the dominant hemisphere. Importantly, though, the signal to the right ear goes to the left hemisphere and vice versa. So if you tend to hear the sound that's going into your right ear, chances are your left hemisphere dominant for language, meaning that your Broca's area and your Wernicke's area are probably located in the left hemisphere.